Hello everyone, good afternoon to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss about question bank from Module 1 and Part B long answer type questions. So we have already solved some question from this part B on module 1 long answer type questions. So today in this lecture I want to solve some more problem on this topic. So problem 1 based on Newton's law of cooling. I want to discuss this problem about Newton's law of cooling. What is Newton's law of cooling? So Newton's law of cooling means when a body whose temperature is theta, that will be put, we have put that body put in air medium, and the temperature of air medium is theta naught, or temperature of the surrounding medium of the body. So after time t, what will be changed in the temperature of the body? So we want to discuss after time t, what is the changing in the temperature of the body. Okay, so this is topic is known as a Coulomb's law. Basically, the rate in change in body, rate in change in the temperature of the body proportional to difference between the temperature of the body and temperature of the air medium. So here basically formula is rate in change in body d theta over dt. This is proportional to minus k theta minus theta naught. Theta is the temperature of the body, theta naught is the temperature of the air medium, and d theta over dt is the rate in change in the temperature of the body at any time t. So now d theta over dt, this equal to I am taking minus k theta minus theta naught. Minus k is a proportional constant here. Minus represented the temperature of the body is decreased. So temperature of the body is decreased, then we get here negative sign. Negative sign represented the temperature of the body decrease. So the question is this: a body kept in air with temperature 25 degrees centigrade Celsius. 25 degrees Celsius, this is the temperature of the air medium. This is the temperature of the surrounding medium of the body, and cool from 140 to 80 degree. The temperature of body cool down from 140 degree to 80 degree within 20 minutes. Now we have to find in this question, when the body cool down up to 35 degree, what is time? What is time? We calculate the time when the body cool down up to 35 degrees centigrade. So this is very easy and very interesting question, also very important, and we should read this question seriously. So solution, let theta be the temperature of the body, and at any time t, the theta naught be the temperature of the surrounding medium. By Newton's law of cooling, we have proof of formula. Newton's law of cooling, there is a relation between temperature of the body. By Newton's law of cooling, we have a proof of formula. In this formula, we have a relation between temperature of the body and temperature of the air medium, and with respect to time. So we have proved this formula, theta equal to theta naught plus c e to the power minus kt. K is a proportional constant. This equation 1. Given us that in our problem, what values are given? Theta naught equal to 25 degrees Celsius. When T is 0. T is 0, then temperature of the body is 140 degrees centigrade. Okay. When time is 0, then the temperature of the body is 140 degrees centigrade. This equation 2. All these three values, theta naught is 25 degree and T is 0 and theta is 140 degree. All three values, theta, theta naught and T, putting in formula 1. Putting value from equation 2 in equation 1, then we get. Formula is theta, theta equal to theta naught plus c e की power minus kt. Putting value of theta 140 degree and equal to theta naught 25 degrees Celsius plus c e to the power minus kt. T is 0 here. I am putting t equal to 0. So minus k into 0. E to the power minus k into 0. This is 1. So next 140 degree equal to 25 degree plus c. C into 1. So we write here c equal to 140. 25 is subtracting from 140. So 140 minus 25 degrees centigrade equal to 115 degrees centigrade. We get the value of c here. C is the arbitrary constant. Integration constant. So we can find apply the initial condition. This is initial condition. T is 0. This is the starting. After apply initially condition. Initially condition. Apply initially condition. Then we get C here. Next one is putting the value of C in given formula this. In given equation 1. So theta equal to theta naught plus C 115 degree equal to e to the power minus kt. This is equation 3. Now putting theta naught equal to 25 degrees centigrade. Then equation 3 becomes theta equal to 25 degrees Celsius plus 115 degrees Celsius e to the power minus kt. This is equation 4. Now when t equal to 20 and theta is 180. T equal to 20 and theta is 180 degree. So the temperature of the body is 80. Cool down. 142 degrees 80 and 25 plus this. Here T is 20 minutes. So here now 80 degrees Celsius equal to 25 degree plus 115 e to the power minus 20k. So finding the value of this e to the power minus 20k we have to find. So e to the power minus 20k equal to 80 minus 25 degrees Celsius upon 115. This equal to 55 upon 115. So dividing by here 5. 5 banja 5, 5 banja 5, 5 2 ja 10, 5 3 ja 15. So 11 by 23. This is the e to the power minus kt. E to the power minus 20k equal to this. This is equation 6. We have find here this relation. When theta is 35, then we have to find t. What is time? When theta is 35. So putting theta equal to 35 in equation 4. So 35 equal to degree Celsius equal to 25 degrees Celsius plus 115 e to the power minus kt. T is unknown here. T is unknown. We have to find here T. Find value of T. Value of T. So e to the power minus kt, this equal to 35 degrees Celsius minus 25 degrees Celsius upon 115. So we had 10 upon 115. This is equation 7. Now e to the power minus kt is 10 upon 115. So here this implied that we write here e to the power minus kt multiply 20 and divide by 20. And this equal to we write e to the power minus 20k and whole to the power, we get the value of e to the power minus kt equal to 10 upon 150. So now some implement we are keeping here. This imply that e to the power minus kt in left hand side multiply 20 and divide by 20. Why we are doing this? Just I am telling you. So this equal to e to the power minus 20k, k and 20. We are taking two number k and 20 and t upon 20. This is the power whole to the power t upon 20. So just I am making this changing in e to the power minus kt. After changing this, we get this result. E to the power minus 20k whole to the power t upon 20. 20 is cancelled, we get same e to the power minus kt. Because this is the power and power whole power. Multiply power to power. X square whole to the power cube. Then we write here x to the power 6. Then multiply in power. 3 to just 6 here. So here this multiply to this. Then we get e power minus kt again. So now this equal to 10 upon 115. But we know that in last equation 6, e to the power minus 20k. I have already find the value of e to the power minus 20k is 11 by 23 from equation 6. Putting in equation 8. From 6, putting in equation 8. Putting in equation 8. Then we have 11 upon 23 whole to the power t upon 20 equal to 10 upon 115. This is equation 9. Now taking log on both sides. So log of 11 upon 23 whole to the power t upon 20 equal to log 10 upon this. So now t, here apply formula m, here apply formula log m to the power n. We write here n log m. So similar here this power goes to b4. So now here t upon 20 log 11 upon 23 equal to log 10 upon this. So this term goes to in denominator. Cross multiply. Then we get here t upon 20 equal to log 10 upon 115 and upon log 11 upon 23. So after solving this with the help of calci, we find value. Now again cross multiply this. So t equal to 20 multiply by log 10 upon 115 upon log 11 upon 23. So after solving this result, we get this. So this is the time. Time is given in minute. So we get time 66.22 minutes. Therefore, at t 66.22 minutes, then theta is 35 degree Celsius. Okay. This is the question. Very interesting problem this, and very easy, very important. So now next. Problem 2. Find the orthogonal trajectory of the family of curve. Orthogonal trajectory of the family of curve. Solution. What is orthogonal trajectory? First of all, what is orthogonal trajectory? What is orthogonal trajectory? Orthogonal trajectory is that curve. Here we have given in problem a family of curve. A family of curve, that is x square minus y square equal to a square. This is equation 1. What is orthogonal trajectory? We have given in problem a family of curve. That is this. This is the family of curve. So what is orthogonal trajectory? Now, orthogonal trajectory, orthogonal trajectory is that curve which is perpendicular which is perpendicular on which is perpendicular or at 90 degree on given curve. Okay, orthogonal trajectory is that curve which is perpendicular, or we can say at 90 degree, which cuts perpendicular or at 90 degree on given curve is called orthogonal trajectory. Okay, orthogonal trajectory. Now, we have given here x square minus y square equal to a square. This is equation 1. We find out a curve. Here we will find a curve which intersect one at right angle at 90 degree. Here we will find a curve which intersect one curve at 90 degree. Okay, then that curve is known as a orthogonal trajectory of given family 1. So how we can find here x square minus y square equal to a square, this equation 1. Differentiating with respect to x on both sides to 1. Then d over dx of x square, d over dx of y square, d over dx of a square. So here d over dx of a square, a is constant, a is constant. So the differential d over dx of a square is 0. A is constant here. Here a is constant. In our question, a is constant. So the differential of a with respect to x is 0. And differential of x square with respect to x is 2x. Differentiation of y square with respect to x is 2y. And again differentiation of y with respect to x, dy dx. This equal to 0. So now 2 is common. We get here x minus y dy dx is equal to 0. This 2 dividing by x minus y dy upon dx is equal to 0 upon 2 equal to 0. So finally we get here x minus y dy dx equal to 0. This is equation number 2. This is the differential equation. This is the differential equation of given a family of curve in problem. Okay, I have found this result. This is a differential equation. This is a differential equation. This is a differential equation of given a family of curve in problem. Now, here we write uh, another differential equation, which is perpendicular to 3 to 2. Okay, so now replacing in equation 2, dy dx equal to minus dx upon dy. So now equation, putting this result into, replacing into this result, then equation putting this result in equation 2, then we get here x minus y and minus dx upon dy equal to 0. So now x this equal to x plus y and dx upon dy equal to 0. Okay. Now integrating this. integrating this x dy. Here x equal to minus y and dx upon dy. Okay. Now variables are separate here. So here writing dy upon y equal to minus dx upon x. Integrating on both sides. This is log y. This taking this side plus log x equal to log c. So now this is log xy equal to log c and log cancel xy equal to c. Okay. So this is a curve. This is equation number 3. The equation 3 is a curve which is perpendicular to the given curve in the problem. It means this is known as a orthogonal trajectory on the given family of curve in the problem. Next question, problem 3. So that the system of rectangular parabolas, hyperbolas, x square minus y square equal to a square and yxy equal to c are mutually orthogonal trajectory. So solution x square minus y square equal to a square, this is equation 1, and xy is equal to c, this is equation 2. Here we are showing that equation 2 is the orthogonal trajectory of equation 1 and equation 2 is the orthogonal trajectory of equation 1 and equation 1 is an orthogonal trajectory of equation 2. One is the orthogonal trajectory of equation 2 and 2 is the orthogonal trajectory of equation 1. So here we have to prove that equation 1 is the orthogonal trajectory of 2. This is the first part. Part 1, here we have to prove that equation 1 is an orthogonal trajectory of equation 2. Okay. So here x square minus y square equal to a square, this is equation 1. Differentiating with respect to x on both sides. Then we get here 2x minus 2y dy upon dx is equal to 0. x minus y dy dx is equal to 0. So x equal to y dy upon dx. Okay. This is differential equation of family of curve 1. Now finding differential equation which is perpendicular to the given family of curve 1. Okay. So replacing here this equation 2, 3, putting dy dx equal to minus dx upon dy in 3. This result putting in 3. Then we get here x equal to y minus dx upon dy. Okay. This result putting in 3. 3 this. This 3 is the differential equation of family of curve 1. Okay. Next, so x here dy upon y equal to minus dx upon x, dy upon y plus dx upon x equal to 0. Integrating on both sides. Here variables are separable. So we can integrate. Then log y plus log x equal to log c. So here log xy equal to log c. So xy equal to c. We get this family of given next curve. So first is the orthogonal trajectory of curve second. Okay. Now next part 2, we have to prove that xy equal to c square or c xy equal to c is a orthogonal trajectory of curve 1. This is curve 2. Curve 2 is an orthogonal trajectory of curve 1. Okay. So xy is equal to c. This is second curve. Now differentiating with respect to x, then x into dy over dx plus y into 1 equal to 0. So x into dy over dx equal to minus y. This is the differential equation. This is equation 3 and this 4 and this 5. We get again 2 this. So now here this is 2. We have taken 2 curve. So this is 5, 4 and 5. This is 5 equation. Equation 5, this is a differential equation of given curve xy equal to c. Now we find a differential equation which is perpendicular to 5. So putting dy dx equal to minus dx upon dy. This is equation 4. Then this equation putting in 5. This result putting in 5. 5 is 5 is this x dy dx means minus dx over dy. We are writing here equation x dy over dx and plus equal to minus y. Equal to minus y. So putting this value here, this equation is 5. This is equation 5. Putting in 5 this result, then we get x minus dx upon dy equal to minus 5. So here minus minus is cancelled. X dx upon dy equal to, here is y, not 5, y. So here is y. Now variables are separate. Variables are separable. This is the method. So here x dx equal to y dy. Integrating on both sides, then we get x square y2 minus y square y2 equal to cy2. So 2 is cancelled. C is an arbitrary constant. Then we get here, x square minus y square equal to c. Okay. So this is the equation number 6. This is orthogonal trajectory on curve 2. So we have proved here, that x square minus y square equal to a square is an orthogonal trajectory of given family of curve xy equal to c. This is first result. And second result, we have also proved here, that xy equal to c is an orthogonal trajectory of given curve of given family of curve x square minus y square equal to a square. Okay, x square minus y square equal to a square. We have proved here also. We have proved. We have also proved here that xy equal to c is an orthogonal trajectory of given family of curve. This second result. First result, we have proved that orthogonal trajectory of x square minus y square equal to a square is an orthogonal trajectory of xy equal to c. So we can say that both curve are mutually orthogonal trajectory to each other. One function is the orthogonal trajectory of the second function, and second function is the orthogonal trajectory of the first function. Why? Because when we are finding the orthogonal trajectory of first curve, then we find second curve. Answer is second curve. And again we have find the orthogonal trajectory of second curve, then we find answer is first curve. So we can say both curve are mutually perpendicular to each other. They are intersect to each other. Curve 1, x square minus y square equal to a square. This is curve 1, and xy equal to c. This is curve 2. These are intersect each other at right angle. These curves are intersect each other at 90 degree or at right angle. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.